possibly make sense. Okay, so when we were coloring the periodic table, I told you guys it was going to be important for you to write these numbers on top of the columns. 1, 2, and then we skipped the transition metals because that's a little past what we need to do. Then we had 3, 4, 5, 6, 7, and 8. How many of you actually wrote those numbers up there? Okay, good. Because these numbers are going to be critical for this part, for these Lewis structures that we're going to do. So somewhere on your periodic table, I encourage you to write valence electrons. Okay, so these numbers, all these numbers tell you the valence electrons. So group 1 has 1 valence electron. Group 2 has 2 valence electrons. Group 3 has 3 valence electrons, 4, 5, and so on. So let's do a little test here. Hold up with your fingers. How many valence electrons does magnesium have? So magnesium's right there. How many valence electrons does that have? 2. All right, good. So it has 2. How many valence electrons does phosphorus have? Okay, good. 5. 5 valence electrons phosphorus have. Now, what on earth is a valence electron? A valence electron is... we're going to go to the notebook and do some practice, but if you have room on your periodic table, you can write it there. Just somewhere where it is useful for you, I'd like to have you write it down. But valence electrons are electrons on the outside of the atom. Now let's think for a second. If these electrons are on the outside of the atom, what is true about them? Are they more likely to interact with other atoms and other things? Yeah. Things on the outside are more likely to touch other atoms or to be around other atoms to interact. So these atoms react or interact, however you want to think about it, with other atoms. Okay. So we are just going to focus on Lewis structures, okay, and that's what you saw the short video on. So I'm going to go ahead and use both my periodic table and my notebook. At this point, I'm going to title this page Lewis Structures. Okay, so when we draw Lewis structures, the first thing we do is we write the element name, or write the symbol. Write the element symbol, and then you find the valence electrons. So where are you going to find the valence electrons? Remember what we said just a second ago? Valence electrons are these numbers at the top of the column. So we are going to look at the top of the column. So we'll go ahead and write that since we didn't have any verbal answers. Okay. And then we seat the electrons. Now I use that word because it makes sense in the practice. So we're going to put it in quotes. I don't think that's probably the word that maybe every science teacher uses. Okay. So I'll let you finish. finish writing that, and then we'll do some practice. Alright, so we're going to zoom out again so we can see a little bit of the periodic table and a little bit more paper. Okay, let's look at hydrogen to start with. Okay, so the first instruction says write the element symbol. So we're going to find hydrogen, and we're going to start here. Hydrogen. The second instruction says find the valence electrons. Well, how many valence electrons does hydrogen have? Show me with your fingers. Just one. That's right, because we're right in column 1. Okay, then it says seat the electrons. Here's the part where in the video it showed you that he put this crosshairs on it. Okay, so if I just have one electron, I am just gonna put right there, just a dot. So the Lewis structure for hydrogen, now this crosshairs thing should become imaginary for you after a while, but as we do a few more, you'll understand why the crosshairs are kind of important. Because when we seat electrons, we start on each side, so maybe the right side, the bottom, the left side, the top, and we go around the table until all of the seats are filled. So we have a seat. We have a seat right here, a seat right here, here, here. 2 seats on each side of the symbol. So if you kind of look at that a little more closely, 2 at the top, 2 on the sides, and 2 at the bottom. So let's look at another element. We'll go ahead and just go across the periodic table to helium. Okay, helium is kind of an outlier in some ways because it is a noble gas, but we'll still look at it. So show me on your fingers, how many valence electrons does helium have? And this is why it's an outlier, because you are correct. When you say 8, you're like, well, it's in group 8, and you said that number tells me the valence electrons. That is true, except let's look at helium. What is the atomic number of helium? 2. So it has 2 protons. If it has 2 protons and it's an atom, how many electrons does it have? It only has 2 electrons as well. So even though we're in group 8, helium is an outlier. You know how in every rule there's an exception? Helium's that exception. So when we think about helium, we're gonna still go through our process. We have these crosshairs. And for helium, we're gonna put our electrons close together. Okay. They're like those people that go to a restaurant and they both sit in the booth seat together. Okay, they're happy, happy. Those 2 electrons are happy, happy. Okay, so let's go into some more, because this one we need to note helium is the exception. Okay, so we'll kind of make him stand out a little bit. Let's go on to some not exceptions. Okay, let's look at lithium. So go back to what you know. Lithium is not an exception. We'll look at our periodic table. How many valence, show me on your fingers, how many valence electrons does lithium have? Just 1 valence electron, because it is in group 1. It has 3 total, but it just has 1 valence electron. So same process, it's going to look a lot like hydrogen. Okay, we have our 1 valence electron, and that's what the Lewis structure of lithium looks like. You might be thinking, okay, this is a little bit redundant, But let's go on to beryllium, which is number 4. Okay. Show me on your fingers, how many valence electrons does beryllium have? I heard I see some 2s. That is correct. So the next instruction says seat them. This is where you want to really look at your seating arrangement. Beryllium has 2, so we have 1, and then we go to the next side. 2. All right. We separate them so that we can see very clearly which ones are lonely electrons. Okay. So even though they're seated at the same element, they're seated at the same table, they don't have a buddy. They don't have someone sitting right next to them to talk to at dinner. So they are lonely electrons there. That will come into play as we get into more bonding. Okay. Give me a thumbs up if this makes perfect sense, and a thumbs down if you're like, I have no idea what you're talking about. And sideways is always an option somewhere. Alright, lots of sideways. So let's go ahead and keep doing some examples, okay? Alright, so if we look at number 5, but in group 3, boron, how many valence electrons does boron have? Show me on your fingers, guys, because I can't hear you whispering. Yep. So we have 3 valence electrons for boron, because if we notice, boron's atomic number is 5, so we have 5 protons. Its average atomic mass is 11, so 11 minus 5 is 6 neutrons, 5 electrons, but only 3 of them are on the outside. 2 of the electrons are really close to the atom. 3 of them are on that outside energy level. So when we look back at boron, we're going to do our crosshairs. We have 3, so we're going to go the first side, the second side, the third side. We'll go ahead and do carbon. How many valence electrons does carbon have? 4. Good. Okay, so we'll do our crosshairs, and we're gonna, carbon has 1 on each side. The first side, second side, third side, fourth side. Alright. Let's go ahead and do nitrogen. How many valence electrons does nitrogen have? Show me on your fingers. 5. Yep, you guys did a really good job looking at that. Nitrogen, it's right here. It's in group 5, so it has 5 valence electrons. Let's look at how we're going to seat those guys. Try to make that straight. We have our crosshairs table, our seats at our table. So we're going to say 1, 2, 3, 4, 5. So this is the first one where you're going to have doubled up electrons. So when you have 5, you start on one side, go all the way around, and then start doubling up. Then start doubling up. So if you were to actually write this on a test or on something, you would not need to leave the crosshairs. It would look like this. 1, 2, 3, 4, 5. If you leave the crosshairs on it, I am not going to count off for that, but you need to know that you don't need those in your answer. Okay. How many doubled up electrons is oxygen going to have? So like this is doubled up, this is paired up. Okay, well, good. Saw a bunch of people show me. So let's go ahead and look at oxygen. Okay. Show me on your fingers how many, how many valence electrons does oxygen have? It has 6. It's good because we look at oxygen on the periodic table. It's in group 6. It has 8 total electrons. 2 of them are on that inner circle, and then the 6 are on the outside. So let's see, how are we going to lay that out? Crosshairs. We go 1, 2, 3, 4, 5, 6. All right. So let's kind of think about this for a second, like where we're going. These guys are buddied up. They're happy. These guys are buddied up. These guys don't have a buddy. How do you think that they could get a buddy, an electron friend? Think about what atoms do. Think about what chemistry is all about. What do you think? Yeah, they're going to combine with another, and that's really good thinking. So when oxygen bonds with another kind of element, that other element's lonely electron comes here and makes a bond. Okay, so that is what chemical bonds is all about, is trying to fill these seats around each atom, trying to make each atom's table full. All right, so let's go ahead and look at fluorine. We'll look at those bonding structures next time we come together. But fluorine, how many valence electrons does fluorine have? So I heard somebody whisper 7. It's hard to show 7 on your fingers, but 1, 2, 3, 4, 5, 6, 7. So looking at fluorine, how many lonely electrons does fluorine have? Just 1. That's right. So we got buddied up, lonely. I don't know about you guys, but I've seen people who, when they look around and everybody has a buddy, they really want a buddy. That's just like this electron. This electron really wants a buddy. And this right here makes fluorine the most reactive element. Okay. So if fluorine is the most reactive element, what do you think is true about neon, which is the next one? Remember, neon is in the noble gases. Neon is in group 8. Let's try to squish neon in right here and look at them side by side. Remember, neon is not an exception. It is in group 8. So how many valence electrons does neon have? 8. It has 8. Okay, so if we start to seat them, we're going to say 1, 2, 3, 4, 5, 6, 7, 8. Does neon have any lonely electrons? No. So this is why neon does not react at all. So we'll go ahead and write that down. No, maybe. So neon, the bigger noble gases, is really easier to see why they don't react, because they're full all the way around. They don't have anything missing, whereas like fluorine has 1 missing. It just takes 1 to get to that full table. So it's pretty easy to snag up 1 electron right there. And if it did snag up an electron from somebody else, from another element, and make a bond, this electron configuration would look just like neon. And it would be happy, it would be stable. Because this is the whole goal of atoms, to become stable like a noble gas. Alright, give me a thumbs up if it makes sense, a thumbs down if you're like, no. I don't see thumbs. I need to see all thumbs. Alright, it looks like we're kind of making sense.